G'day again. 14A. In a theme park ride, a chair is released from a height of 110 metres and falls vertically. Magnetic brakes are applied when the velocity of a chair reaches 37 metres per second. They give you this nice picture. Magnetic brakes are somewhere. 110 metres. Nice not to scale picture there. Very helpful. The height of the chair at time t seconds is x metres. The acceleration of a chair is given by acceleration, which is x double dot, equals minus 10. At the release point, t equals 0, x, which is displacement, equals 110, and x dot, which is velocity, equals 0. Using calculus, there's two parts, we'll do one at a time. Using calculus, show that x, which is displacement, equals minus 5t squared plus 110. This should be fairly straightforward. There's a lot of information there, but actually doing this should be relatively straightforward. So let's have a go at that. We'll start with acceleration and you'll just work your way to displacement. So we've got acceleration equals minus 10. How do you get from acceleration to velocity? Well, you integrate. So let's do that. So we want to get the velocity, which is x dot. So to get that, we're going to integrate that. So we integrate that, and we're integrating with respect to time because that's the only other thing that's in the equation. So integrate that with respect to time, and we get that x dot, which is velocity, equals minus 10t plus c. Next step, figure out c. You're told that x dot equals 0 when t equals 0. So if I make that 0, that's nothing. So this is 0 when this is 0 plus c. So guess what? Easy one. Therefore, c equals nothing. Next step, we're going to integrate that to get displacement. So let's integrate that. So displacement is going to equal integrate x dot. So we're going to integrate minus 10t. So x, which is displacement, so I don't know if we should write that, so that's velocity, that's displacement. So you can look at it again later. Alright, x displacement, x dot that, and that's acceleration. So we're going to integrate that, so raise that to a power, new power underneath, so minus 10 t squared over 2 plus c. Guess what? You've got to figure out what c is. So go back to the question and see if there's any helpful information like t is 0 and displacement equals 110, and let's put that in. So we're going to get 110 equals, this is 0 because it says t is nothing, so nothing plus c. So guess what c is? 110. And that's it, you're done. You've got to your equation, you can say therefore x equals minus, well 10 over 2 is 5 plus 110, and that's it, you're done. G'day again. So back for part 2. So in the first part we figured out acceleration minus 10, velocity minus 10t, and we've shown that displacement is minus 5t squared plus 110. Second part, how far has the chair fallen, so how far has it dropped when the brakes are applied? And there's a little trick to this question. Let's see how we go. So the only thing we know is the brakes are applied when it's 37 metres per second, when the chairs reach that speed. However, the velocity is negative here. It's negative multiplied by time. So you need to apply this as negative 37. So you've got velocity equals minus 10t, which equals minus 37, okay, because it's going downwards. And these equations are based looking upwards, and that's a big trick, okay? If that's going downwards, then this velocity is actually going negative. So when that equals that, well, pretty easily, t equals, divided by minus 10, 3.7 seconds. Okay, so that's pretty easy. We're going to put that into your displacement. So you get x equals minus 5 multiplied by 3.7 squared plus 110. Punch that in your calculator and you get 41.55 metres. Now you'd think, great, I've done it. I figured out the question. But you haven't, okay? Because this is the displacement from the ground, okay? And that's the trick. That's why I said there's a trick in this. How you want to know how far it's fallen, so you've actually got to go 110 because this is 110 and we're going downwards minus 41.55. So it actually equals 68.45 metres. So this is how high it is. And this is how far it's fallen. Tricky little question. And you're done.